Hello, I'm Rebecca the Maths Lady, and welcome to video 12 in this series on teaching number to children aged 9 to 11. And this video is all about problem solving. In this video, I'm going to explain how we ensure that children become great at solving written problems about practical situations. We'll look at the mathematical skills they need, we'll look at the vocabulary skills they need, and then we'll look at how you teach problem solving so that you understand exactly what children are struggling with and know how to help them. And finally, I'll talk about where you can find further professional development on this from other providers and some suitable resources. So if you don't need this video, here's a skip link to your next one, which is all about equivalent fractions and comparing fractions. And I'll mention some previous videos that you might find useful as we go through this video. So let's get started. Teachers tend to find that children either can solve problems or they get stuck with them, and it's really difficult to help them. It's really important that we unpack exactly what's going on, why some children are thriving while others struggle, and then we can understand how to help them. So the children who tend to fly usually have two things. They have a really deep structural understanding of the maths that's relevant to the problem. And they have really good vocabulary skills, which are usually linked to great literacy skills. Now, I've deliberately put this video into number straight after the videos on addition, subtraction, multiplication and division, because that creates a real opportunity to highlight what's going on with the structural issues. So when word problems are about addition, they tend to be about counting on or finding a total. And if children have done lots of practical work and come to deeply understand those ideas, they're going to find those problems easy. They are going to confidently understand that structure. But subtraction is much harder because they need to be confidently swapping between subtraction as take away and subtraction as finding the difference or counting on. When problems are set, they need to be able to decode that both those types of situation are subtraction. And once they've done that, they need to choose take away or counting on to solve the number part of the problem, depending on which is easiest. So you can have a problem that's all about finding the difference, but it might be best to solve it by taking away, and vice versa. Now, if that makes perfect sense to you, then you're fine. If you're struggling with that, here's a link to a video on the foundations of subtraction, which really deeply delves into those issues, and there are some practical problems in those videos which bring that clash of structures to life. Multiplication problems tend to be relatively easy for children to decode because they're usually repeated addition of groups the same size or scaling. But with division, again, we have this huge clash because it can be sharing fairly, or it can be counting equal groups, or it can be scaling. And children need to decode all those models as being division, and then they need to pick the structure that works best for the numbers they've got. So it's hugely complicated. There's a lot going on. And again, here's a link to a video on the foundations of division, which really brings that to life and shows some of those clashing problems where they're written as a counting groups problem, but it's best to share fairly, and vice versa. So if children have not really got their head around those mathematical structures, then they are going to struggle because they simply won't be able to decode the structure of what's going on in the problem and swap freely between the different images of subtraction and division, and they need to be able to at this stage. If the problem is about domain-specific maths like percentages or money or measure conversions or something like that, then they need to have really clear images of what's going on with that topic in their imaginations as well. And if you've watched my video on the relevant topic and you've taught to ensure that they have that structure, then they will be okay with their structural understanding of maths. And that leaves one type of problem, which is the type of mathematical problem which is more like a puzzle, where they're not using any specific area of maths that you've taught them. So a great example of that would simply be to work with Cuisenaire rods and to ask them how many ways they can find to make something this size that's 4 units long with different types of blocks and patterns of blocks. And that type of problem is all about, first of all, playing around with it to make sure that you've got a deep sense of what the question is asking, and then starting to work systematically to try and find all the options and know that you've found all the options. And if they're struggling with problems like that, they simply need more practice. Another one would be to give them egg boxes for 6 eggs and 3 things that are representing eggs, whether they're real eggs or Lego cubes or whatever, and ask them to explore how many different ways can you put 3 eggs into an egg box. So children need a deep structural understanding of their maths to be able to fly with problem solving. The other thing they need is really good vocabulary. And the best thing to do here, if they're struggling with problem solving, is to get them to tell you the problem in their own words. And you'll quickly find out if they've got specific gaps in their vocabulary that you need to fill. If you're just working with 1 or 2 children, or only a few of your children have got specific problems, you'll probably be able to fill those gaps pretty quickly just by explaining the vocabulary to the children at this age. But if you've got a bigger problem, you've got whole classes of children who are struggling with some of the vocabulary, there's all sorts of games you can play. From simple exercises where you ask the children to put the words into sentences, to getting them to act out the words or describe it without using the word, to find antonyms and synonyms of the word. And here I'm going to recommend a lady who's really brilliant at teaching teachers how to work on mathematical vocabulary with children. And her name is Jean Knapp. She provides professional development. Her website is jkprimarymaths.wordpress.com. And if you go to courses and bespoke support, when I looked there, she was offering an hour's training for teachers for just £30 by conference call. That's awesome. She's brilliant. It's well worth it if you decide that's what you want to work on. And now we've made sure that the children deeply understand the structure of the maths behind a problem and they understand the vocabulary, they need to start working on problems. So what do we do if they're getting stuck? Well, one thing is to make the numbers really easy, to see if it's just having complicated numbers that's puzzling them. Another strategy is to take the numbers out altogether and just replace numbers with the word sum and see if they can make sense of the maths that they need to use. A third strategy is to reduce the number of steps in a problem, and children should be working on multi-step problems by now. But if they're too complicated, can you strip out one step of the problem that you'll be able to put back in later while children focus on part of the problem? If you work through maybe 2 problems in a session, but you do it deeply, slowly and thoroughly, that will be a really powerful session. And if you'd like further training on this area, I'm going to recommend Jean Knapp again. I think she's just brilliant and she understands this aspect of problem solving much better than I do. So what you need now, of course, are lots of great problems to solve. One place to go for them is Gareth Metcalf's IC Maths YouTube channel, and you're looking for his Year 5 and 6 videos, which are age 9 to 11. Another place is Enrich, and they're particularly brilliant for your problems that aren't based in any specific domain of maths, that are really going to stretch children to see them as puzzles and start to find their own strategies for solving them. And then, of course, if your children are going to do test papers, there'll be some really good problems in the past test papers that you'll find useful. Examiners spend a lot of time setting up those questions and they're usually really well thought out. Your extension work for this topic is so obvious, and of course it can be the extension work for lots of other topics as well, and that is just to get going with problem solving. And it's a really great idea once children have really got the hang of a topic to give them a problem solve that's on a completely different topic, because that challenges them to puzzle out which maths they need to use, rather than just letting them assume that it's the same maths that they've used during the lesson. So your takeaways from this video are that in order to deeply understand problem solving, children need to first deeply understand the maths that's relevant to the problem they're trying to solve. And that's not as easy as most people think it is, especially with subtraction and division. They also need to have really well developed vocabulary, and if they haven't, you need to identify that and specifically address it. And then when you work on problems, you need to work on them slowly, especially if children are struggling. You need to take them apart. Make the numbers simple if that helps. Take the numbers out completely if you just want to focus on the structure of what you're doing. Reduce the number of steps until you puzzle out exactly where the barriers are that each child is facing. And you'll find lots of great problems for your children to work on the Enrich website, on Gareth Metcalfe's I See Maths YouTube channel, and in past papers. And of course, bring problems in from the world around you. By the time children are 10 or 11, you could set them the problem, how many daisies are there in the field? And they have to do experiments to throw metre squares and at random to try and find the average number of daisies in a metre square, and then find the area of the field, something like that. But let them puzzle out their own strategies. They've got to find a way of doing it. And if you've got a child who's determined to count them all, let them, and then get every child to present their strategy to each other at the end of the session. So be creative, use the world around you, and make cross-curricular links. Have a think, are there things you're doing in other subjects that would make great maths problems? That's it. Off you go and have some fun with puzzles. Bye for now.